Hi everyone, this lesson 4.1 is the first lesson of our last unit, and this unit's focusing on statistics. So in this lesson, I have two parts. This first part is going to introduce you to what are called tabular and graphical representations of data. So we're going to talk about histograms, bar graphs, pie charts, those types of graphs or representations of data that you've probably seen in many other courses. So the first part is going to introduce you to some terms, the basics of them. The second part of this lesson is going to actually show you how to start with a group of raw data in Microsoft Excel and quickly make tables, actual tables in Excel, as well as a pie chart, a bar graph, and a histogram. Okay, so follow along with kind of both pieces, and just know that a lot of what we're doing here will directly be seen in practice in Microsoft Excel. So like I said, this unit focuses on statistics. So what we're going to look at in this first lesson is taking raw data and processing it into formats that are easier to understand. So this raw data can come from anywhere. So I've used it where I have data logger information coming from buildings where I'm looking at temperature and humidity. It could be data if you're curing concrete, okay, what the outside air temperature was, okay, all of that comes just as raw data, whether it's just the date and time, and what the measurement was. That's raw data, and raw data has been collected, but it hasn't been organized in any useful fashion, okay? So seeing in a spreadsheet this two columns of data and there's 5,000 entries, that without it being organized isn't that useful. So what we're going to do is look at how to transform that raw data into something that you can actually read and output and provide to supervisors, provide to clients. So that's our first term, is raw data. The second term I want to talk about is what a population is versus a sample. So a population is a complete collection of elements. So for an example, population of Canada, okay, 37-ish million. That's the entire population of Canada. A sample is a subset. So maybe it's all individuals between the ages of 18 and 24. That's a subset of our entire population. So that's what's known as a sample. So when you're looking at data, a sample might be that you collected data using a data logger on site, but only from 8 a.m. to 5 p.m. or only overnight from 5 p.m. to 5 a.m. Right? So that's a sampling of the data because it isn't representative of the entire piece necessarily. You can make conclusions based off of it, but it isn't the entire population of data. The last piece is our variables. Okay, so there's two types. There's quantitative variables, which are ones that can be quantified numerically. In other words, you can assign a numerical value, 1, 2, 25, whatever it is, easily. Okay, so a good use of that, again, if I go back to data loggers, is if you're measuring temperature. Those are quantitative variables because you know that if it says 25 degrees Celsius that day, it's a quantitative measurement. Qualitative are variables that have a value, okay, but sometimes or often they can't necessarily be quantified numerically. Okay, so we can look at qualitative variables when we talk about pie charts, and we talk about some versions of bar graphs. So the first item I'm going to talk about is graphing quantitative data. And we're going to look at that by looking at what's called frequency distribution. So what we have here in this instance is we have a large sample of data with numbers that are kind of all over the map. Let's say it's 1, 2, 4, 20. Okay, and you have numbers that repeat each other, but it's just a collection of data. And you want to figure out a good way to organize it. One way you can do that is you can sort it into what's called bins or classes. Your textbook uses the term classes. I often refer to them as bins, so that's how I will refer to them in the course. It's also how Microsoft Excel refers to them. So basically what you're doing is you're taking the data and you're picking, groups. So in this case, let's say we had a group from 0 to 5, a group from 5 to 10, okay, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. You can see I have that listed in this table. So for this, every measurement that falls within this variable, so from 0 up to 5, but not including it, you dump them all into here, okay? If it falls between 5 and 10, again, including 5, but not including 10, I'll explain why in a minute. You bundle them all into this bin, okay? And you keep going. Everything between 10 and 15, 15 and 20, 20 to 25, and 25 to 30. You're basically throwing the data into each of these bins. And what that does is it allows you to create a graphical representation at each of these sets of frequencies. Because if we decided to graph every number individually, that data isn't overly useful, okay? So the example you're going to see is hours of exercise. So you might group people into exercising 0 to 2 hours a week, 2 to 4 hours, 4 to 8, etc. Okay? So those are what are called bins. So when you're creating a frequency distribution, you often take, the whole range of your data. In this case, if we look at it in the instance of this table, we have values from 5 all the way to 30, okay? And what you do is you break that down into bins of equal width. So in this case, we did 5 bins, and their width was 5, okay? So we have 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. So that's known as the bin size, okay? The next term is our lower and upper bin limits. So our lower bin limits are simply the first number in each of these bins, okay? So it'd be 5, 10, 15, 20, and 25 for the lower bin limits. The upper bin limits, okay, are the second numbers within these bins. Okay, so 10, 15, 20, 25, and 30. So with each one of these, all right, we have a certain number of observations that fall within that. That's known as the frequency. Okay, and then we have our total number of observations. How many data points do you have? In this case, we had 227. So what we can do is we can actually do two things. We can either graph the frequency that they occur, or we can graph the relative frequency, okay, which is how many times it occurs in that certain bin divided by your total number of observations. So for this first instance, the relative frequency between 5 and 10 would be our frequency divided by our total number of observations, which is 227, multiplied by 100%. Okay, because if you just did 40 divided by 227, you'd get something like 0.18. But you multiply that by 100% to get it in a percentage, which gives us 18%. So that's how the relative frequency is calculated. Okay. So each of these, this kind of bin sizing method is very useful when you have data that covers a broad range of values. Okay, so it doesn't fall within specific values throughout the process. Putting them into these, convenient bins helps you to organize it better. So, like I said, when you put them into bins, okay, now what you see is you have 227 observations, if you remember, and they were all over the place from 5 to 30. So if we graphed this with 25 different bars here, it's hard to discern a pattern. But when you put them into certain widths, again, equal width bins, you start to see how the data is distributed. What you see here, this was average monthly orders, and what actually the data was for was monthly orders for a food ordering program like Good Food or HelloFresh, which we're going to use the same data when we look at the Microsoft Excel piece. And what we have here is now you can see that, oh, the two highest bars were for between 10 and 15 and 15 and 20 orders. So in other words, people order between 10 and 20 orders a month most often. And the reason you can see that is what we've graphed here. This is what's known as a histogram. What we've graphed here is on the x-axis, we have the average monthly orders, and each of these is our bin. So 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. And the bars are together, meaning they're directly side by side. There's no gap between them here. On the y-axis, we see frequency. Okay, so how often these values occur within each bin. Okay, so that's what we're graphing here. Microsoft Excel will actually graph this for you directly if you ask for a histogram. Again, we're going to get into that in part 2 of this lesson. So what you see here is because we grouped the data together into what's called a histogram, a pattern emerged, right? We turned this raw data, and it was 227 observations. When we get to part 2 of this lesson, you're going to see exactly what that raw data was. We turned it into something useful, right? Graphing this data suddenly made us realize that 10 to 20 orders a month is what most people order. In this instance, that's what the data was, okay? Alternatively, if you didn't want to do it as a histogram, that's the common way that you see it done in Microsoft Excel. You can do what's called a frequency polygon, which I actually prefer the histogram better, but some people have a better time reading, this type of graph, which is known as a line graph. So what we do here is, if you remember, we had our bin sizes. So what we do is we're graphing them as a point instead of a bar. So on our histogram, we had them graphed at 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. Here, we're actually plotting it at a single point, which is halfway in between the bins. So halfway in between 5 and 10 is 7.5. 10 and 15 is 12.5. 15 and 20 is 17.5. 20 to 25 is 22.5. And 25 to 30 is 27.5. So you can see that I've graphed on the x-axis the same piece, except at each of those points, which is halfway between the bin width. Okay? The y-axis remains unchanged. It's still the frequency that it occurs in each one. So 40, 68, 74, 22, and 23. So some people prefer line graphs. I actually prefer the histogram, okay, because it actually shows you the bin width here instead of the piece in between, and it also shows you an actual graphical piece with bars. Okay, so if I were to draw bars over this to be a histogram, I'd get the same graph that I had with at the start. Okay, going back to our histogram, it doesn't change. It's just a different way to represent the data. Again, histograms are the most common, but it's totally up to you as to which type you choose when you're trying to represent it graphically. Okay, there's many more options than just these two. Okay, so let's look at an example. This is going to be, doing this by hand. Again, we'll go over it in Excel, just so you do it automatically. But what I want to do is I want to construct a histogram and a frequency polygon using an appropriate bin size for the following data that sits over here, on exercise hours per week for students. Okay, so when you look at this question, there isn't like an aha moment and you have a bin size. It's one of those items that you could pick that your bin size is from 0 to 2, 2 to 4, I should say. Okay, 0 to 2, I'll redraw it. 2 to 4, 4 to 6, 6 to 8, etc. Okay. What you'll see is you'll have one too many, which is okay. Or you could do different bin sizes. What I'm going to pick is I'm going to pick a bin size of 4. Okay. The reason I'm picking that, again, I could pick 2, 3, 4, 5, is it clumps this into 5 different sets of data. So your general rule is you don't want to do too many bins, 10 or 12, because then at that point you might as well just graph all 17 of these points. You don't want to do 2, right? Because then you're really only comparing half and half. So you're not getting a quality comparison between them. Okay, so somewhere where you're getting, an adequate amount of bars, in this case, if I pick 5 bins, then I'm getting a way to actually see this data a little bit clearer. So if I do that, okay, remember when we talked about it, we had bin widths. The lower bin width counts in the frequency, the higher one does not. So if I break this up into groups of 4, I have 0, 1, 2, and 3 as my first bin, which would be 0 to 4 because it does not include 4. 4, 5, 6, and 7 in my second bin. 8, 9, 10, and 11 in my third bin. 12, 13, 14, and 15 in my fourth bin. And then my fifth bin would go from 16 to 20. Okay, I don't have results past that, which is okay, right? It just means that there isn't data other than this 16 that falls within that bin width. So if I write this out, okay, I'll write bins 0 to 4, 4 to 8, 8 to 12, 12 to 16, and 16 to 20. Then I will write my frequency. Okay, frequency is how many times it occurs in each bin. So going to our data on the right here, for the first one, we have 6 plus 2 is 8. Okay, plus 6 is 14, plus 5 is 19. So this bin sums to 19. For our second bin, from 4 to 8, we have 7 and 9 is 16. Plus 3 is 19, and 3 is 22. Okay, just adding up our frequencies together. So if I rate them here, we get 19 and 22. For our third bin, we have 3 plus 0 is 3, plus 2 is 5, plus 1 is 6. Okay. For our fourth bin, we have 1 plus 0 is 0, plus 1 is 2, plus 0 is 2. Okay, so we just have 2 here. And for our final bin, we just have 1, right? The only value, which is in 16. Okay. If we add these up, 19 and 22 is 41, plus 6 is 47, plus 2 is 49, plus 1 in our last bin is 50. So our total number of observations is 50. Now, if I asked in this question, you could have found the relative frequency using our total number of observations, which is 50, and our frequency for each one here, but I didn't ask that. What I asked now was to construct a histogram and a frequency polygon. So our histogram, if we were to draw that, okay, I'll draw our y-axis and our x-axis, okay. So on our x-axis, I'm just going to write our bin widths. So 0 to 4, okay, or if you're in Excel or in other software, you might see 0, 4 with square brackets. Either way you can write it is acceptable to me. 4 to 8. So I will keep the same and write it with square brackets, 4, 8. I'm drawing these dashes just so I know where to draw the bars. Then we have 8, 12 with a bar. Then we have 12, 16 with a bar. And lastly, 16, if we went all the way, it would have been to 20, right? We didn't show that here, but again, it's bins of 4. So in each one of those, you can graph the frequency. So I'm going to just pick lines here, 5, 10, 15, and 20. And now we can draw our bins, okay, or our bars for each part of our histogram. So for 0 to 4, we have 19, so it's going to sit just under 20. For our second bin, we have 22, so we're going to go a little higher. And then we have a drop off. We have 6 for our next bin, 2 after that, and 1 after that. So you can see when we broke it up into 5 bins, we were actually able to see that most individuals in this particular sample exercise between 0 and 8 hours a day. And when we see it in Excel, you might see these colored in all nice. Okay, this is not nicely colored in, but colored in nonetheless. And you see that in the later bins, from 8 to 20 hours, it's very few, right? Now, if you just look at this data, okay, that doesn't mean much, right? Yeah, we can see a couple zeros here, where they're not getting exercise, and maybe we can see that a few numbers here are higher than the numbers at the end. But in general, this raw data doesn't do us any good. It's not providing useful information. Versus doing it in a format such as a histogram here, or a frequency polygon, which we're going to talk about next, allows us to actually understand this data better. So if we want to do this as a frequency polygon, remember we had our bins, 0 to 4, 4 to 8, 8 to 12, 12 to 16, and 16 to 20. And we had our frequency. So we had 22 for the first bin. Okay, actually, sorry, we had 19. For the second bin, we had 22. For the third bin, it dropped to 6, and then 2, and then 1. Okay, that's just our data from our previous info. Now the frequency polygon looks very similar. So we'll start with our graph. Again, with our same y-axis, 5, 10, 15, and 20. But on our x-axis, as opposed to doing the full width of the bin, so both the lower and upper numbers, we're going to use the number that's halfway in between each of these numbers. So halfway between 0 and 4 is 2, 4 and 8 is 6, 8 and 12 is 10, 12 to 16 is 14, and 16 to 20 is 18. Okay, those are what are known as bin marks. Okay, so instead of seeing it as that full width bar, this looks like a line graph. So we can draw these out. Okay, 2, 4, 6, 8, all the way, 10, 12, 14, 16, 18, and 20. Now we're only going to graph them, of course, where it actually occurs. So at 2, remember halfway through the first bin, we had 19. So I will graph a point here. At 6, halfway between the second bin, we had 22. Then we had a drop to 6 for the third bin, dropping us down to here. Then in our next bin, we dropped all the way down to 2 before finishing at our final bin of 1. Okay, and in a frequency polygon, these are simply connected together. Okay, so this is just a different way to show it, right? With each point, which I'll put a little larger so you can see a little better. But drawing it out as opposed to using bars, using a line graph. Now, like I said, I like the histogram better. I find it's a better representation of the data. It also shows you the whole bin width down here as opposed to just the points that we graphed here. okay? Because the 2 doesn't tell the whole story. It's halfway in between a bin width, but the bin could be 4, it could be 8, could be 16, okay? Just something to keep in mind for that. So our next item I want to talk about is graphing qualitative data. Okay, so quantitative data, everything we did in our last example with hours of exercise, those are quantitative measures. Meaning you can ask somebody how many hours they've exercised, and they say 2. And you understand, if it's in hours, that's 2 hours of time. But there's other measurements taken, for instance, a date or a time, okay? A date, let's say it's March 14th, 03/14, 2020. Those are numbers, but it's not, you can't quantify that in terms of an overall number, okay? Those types of data are known as qualitative data, okay? Another version of a qualitative data might be that, you look at the percentage of something. How many people buy a PS4 versus an Xbox versus a Switch, okay? Versus even a Nintendo DS, or I guess 3DS it would be, okay, when they were coming out. How many people buy each of them, or how many people have none, okay? So you could have quantitative values to each of these, 20, 10, 14, 6, and 30. Qualitatively, maybe you want to find the percentage that each of them falls into. That is useful when you look at something like a pie chart. So a pie chart actually shows the proportion of observations in each category, and it's represented by a wedge in a pie. Okay? The larger the wedge, the more time, the more observations you see. So for instance, the smallest wedge in this example would be the 3DS, that's 6. The largest would be that no people have a console with 30. Okay? So the size of the pie increases in size proportionally for that piece as more observations fall under it. Okay? That one is useful, and visually you can kind of see this, but how do you know if this is 40% or 30%? Okay? It's hard to tell based off of that. You can add data labels to it to make it easier, but still, ultimately it's harder to read that data in a pie chart. So a lot of times instead you see individuals use bar graphs. Okay? So in bar graphs, you'll see the actual breakdown for each individual piece represented by a bar. Now the difference between this and a histogram, each of these are set items. Okay? They're not bins. They don't fall within a certain bin. It's a specific reference to an item. And you notice the bars are separated, right? Because they're not in any way related to each other. So when we looked at bin widths, they were related, right? They were equal width bins that your data was kind of clumped into. And that's not the case here. It's specific items that you're relating. Okay? So these ones, we won't do an example in our PowerPoint, but instead I'm going to show you in Microsoft Excel in the second half of this how we actually create those using raw data. Okay? So that was it for part 1. These examples here are asking you to do something similar to what I showed in this first part of the lesson, which is you looking at breaking data up into bins or classes, as your textbook calls it, as well as looking at doing histograms and frequency polygons. The second half of this video is dedicated to teaching you some basics on how to start with raw data and turn it into different types of charts or tables using Microsoft Excel.